Welcome to 2.3 Polynomial Functions Part 3. We are still talking about what information we can determine from a graph of a function, and then what is a quadratic function. A strategy for graphing polynomial functions. So, there are many steps in order to graph a polynomial function. We're going to go through them. I'm going to read through all of them and then we'll do an example. So step 1, use the leading coefficient test to determine the graph's end behavior. Step 2, find x-intercepts by setting f of x equal to 0 and solve the resulting polynomial equation. If there's an x-intercept at r as a result of x minus r to the k in the complete factorization of f of x, then a, k is even, the graph touches the x-axis at r and turns around. B, if k is odd, the graph crosses the x-axis at r. And C, if k is greater than 1, the graph flattens out near r, 0. So step 3 is find the y-intercept by computing f of 0. 4, use symmetry, if applicable, to help draw the graph. So A, y-axis symmetry if f of negative x equals f of x, and origin symmetry if f of negative x equals negative f of x. And finally, step 5, use the fact that the maximum number of turning points of the graph is n minus 1, where n is the degree of polynomial function, to check whether it is drawn correctly. So we're going to take this one step at a time and graph this. So step 1, determine the end behavior. So we know, in this case, our degree, or n, is 3, because x squared times x is x to the third. So that's odd. Our coefficient is 2. So you know you're going to have something similar to that. Nope. Sorry about that. So you will have a graph, because you have your odd, and then you have a positive, so it's going to go opposite ways. Step 2 is find the x-intercepts, so zeros of the function, by setting f of x equal to 0. So we have 0 equals 2 times x plus 2 squared times x minus 3. So in this case, you know that if you had either one of these be 0, then your entire equation would be 0. So you have x plus 2 equals 0, and x minus 3 equals 0. So you're going to have a 0 when x equals 3, or x equals negative 2. Your multiplicity is 2 here, and your multiplicity for 3 is 1. So that means it's going to touch at 2 and cross at 3. Step 3 is find your y-intercept by computing f of 0. So that means you're going to have a point 0, negative 24. So it crosses your y-axis at 0, negative 24. So to help us determine how to scale the graph, we want to evaluate f of x at x and at 2. Once you do that, you will realize how your graph will lay out in the end. So you want to know how steep it needs to be or how shallow it needs to be. So our partial graph illustrates that we have neither x-axis symmetry nor origin symmetry. Using end behavior, intercepts, and additional parts, we graph the function. So use the fact that the maximum number of turning points of the graph is n minus 1 to check whether it is drawn correctly. So that means you know that you have a degree of 3. So n minus 1 is 3 minus 1, which is 2, and you have 2 different turning points. Please make sure you take the questions at the end, and I will see you in live class. Work on your homework. BVIM me if you need any help.